Good morning. Here we are on day 3 of dilations, and here's our objective. I will be able to check whether one shape is a dilation of another and identify the scale factor. Okay, so just as a reminder, our dilated points is our original times our scale factor, and the reverse of that is that our, where can I write this? Our scale factor equals our dilated value divided by our original. So, to find the dilation, we're dividing. To find the scale factor, to find the dilation, we're multiplying. To find the scale factor, or the original actually, we're dividing. Okay, we just have one to do together, and then you're on your own. Triangle ABC is shown on the coordinate plane below. The triangle is dilated from the origin by a scale factor r equals 1/2. Identify the coordinates of the dilated triangle A prime, that should actually say just A. Nope, I'm wrong, my bad. The dilated triangle A prime, B prime, C prime, and draw A prime, B prime, C prime below. So we're going to start with our original coordinates. Our original coordinates, I realize these numbers are a little hard to see. We have A at -10, 6. You don't need to actually read those. You can just count. Here's 0. And we're counting back 10 and up 6. B, which is -11, 2. I'm leaving space here so that I can multiply. And C is -4, 4. Now, in order to get my dilated points, I'm going to multiply the original by my scale factor. My scale factor is 1/2. Now, if you remember, multiplying by 1/2 is the same as dividing by 2. So I'm really just dividing all of these numbers by 2. So A prime, we're dividing both of these numbers by 2. -10 divided by 2 is equal to -5. 6 divided by 2 is 3. So there's our first point. For B, we're also dividing by 2 to get B prime. -11 divided by 2, well, I know that's going to be negative. And 11 divided by 2, 10 divided by 2 is 5. And then an extra 1, so it's -5.5, 5.5. 2 divided by 2 is 1. And lastly, C, we're still dividing both of those by 2. We get C prime. -4 divided by 2 is -2. 4 divided by 2 is 2. So there's our 3 points. The next step is to draw A prime, B prime, C prime below. So I'm going to plot these points. We have -5, 3 is A prime. We have -5.5, that's the middle of 5 and 6. 1 is B prime, and -2, 2 is C prime. Okay, so some things we need to notice are that when something is dilated, the lines, they stay parallel. So AB is still parallel to A prime, B prime. BC is parallel to B prime, C prime, and AC is parallel to A prime, C prime. If you took a ruler, which I don't have in front of me right now, if you took a ruler and just, if you have AC right here, if you slit it down, it's going to be the same line. This ruler is way too big to see that, but so which lines are parallel? AB and A prime, B prime. BC and B prime C prime, and AC and A prime C prime. Okay, so the lines are still going the same direction, they're parallel. Also, the angles are the same. So this angle, if you get a protractor and you measure, you will see that these two angles at B, they're exactly the same. These two angles at A, they're exactly the same, and these two angles at C, they're exactly the same. So dilations preserve angles. Preserve angles. Okay, so overall, when a dilation happens, what stays the same or is preserved and what changes? So what is preserved is the orientation. The orientation is which direction it's facing. That's why the lines are parallel. The angles are also preserved, as are the signs of the numbers. What changes? That says changes. I'll write that more neatly. Changes is the location of the points, the length of the line segments. Okay, so we're going to practice, you're going to keep practicing dilating things, and we're also specifically focusing on noticing what lines are parallel, what angles are preserved. Have fun!